Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about the I/O structure of a computer system, how the I/O operation takes place, and why DMA is effective and why should use the system structure as well as the system switches along with the bus structure. Storage is only one type of the many I/O devices available. A large portion of the operating system code is dedicated to manage these I/O devices, not only because of the importance of reliability and performance of the system, but also because of the varying nature of the devices. As we know that a general purpose computer system consisting of one or more CPUs and many device controllers connected through a common bus. These device controllers, depending on, we can decide that one or more devices can be attached to it or not. Now this bus structure allows us to hear some shared determines. Now the shared properties of this. A device controller contains and maintains some local buffer storage as well as a peripheral device and special set of registers. This includes the movement between the data of peripheral devices to the local buffer storage and vice versa. This device controller operating system uses as a device driver which understands this device controller and performs an uniform interface to the rest of the operating system to that device controller. Now to start an I/O operation, first the device driver controls and loads appropriate registers within this device controller. This device controller in turn examines the content of these registers and decide what operation is to be taken. Now the device controller starts the transfer of data from the peripheral devices to its local buffer. Once the transfer is completed, the device driver then interrupts the operating system and the device controller sends an interrupt to the device driver to tell him that it has finished its completion. Now the device driver tells the operating system that you may now resume your operation and the CPU can accomplish the other tasks. The device driver returns the control to the operating system either via an interrupt for the operation is to be a read, for some other operation it sends the status information. Now this interrupt driven I/O is fine for small amount of data, but it can produce a high overhead if it is used for a large and bulk amount of data known as disk I/O. For there, a DMA, direct memory access, is used to access the shared memory for a better environment and performing speed. Here, after setting up the buffers, pointers, counters and registers to an I/O device, the starter of the transformation of an entire block of data from the memory devices to the local buffer storage. Now the device controller generates an interrupt per block to tell the device driver that it has finished its completion. Now, no generation without any intervention of the CPU is generated per byte for some low-level devices. So the entire block of devices is now coming to the per byte and per byte is reduced to the entire block of devices. While the device controller is performing this operation, the CPU is available for accomplishing other tasks. Now some high-end system uses switch structure rather than using bus structure where all components can talk to each other without competing for the shared cycle on a bus. Here the DMA is even more effective. Now by this the I/O structure operates. The DMA is effective usage of this I/O structure. That's all for this video. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.